In this video, I'm going to show you how to carry out a chi-square test in SPSS. A chi-square test is a hypothesis test that's usually used with ordinal or nominal level data, and it essentially tells us whether or not there is a relationship between two variables. That's why it's also known as the chi-square test for independence. Being that it is a hypothesis test, it has both a null and a research hypothesis. The null hypothesis is that there is no relationship between the two variables that you're looking at, that they are independent of one another in the general population, and the research hypothesis is that there is a relationship, or they are not independent of one another. So for this example, I'm looking at the world values lab data set, and it begins a lot like our last chapter with creating a bivariate table. So we're going to go to Analyze, then we're going to go to Descriptive Statistics, and from there we go to Crosstabs. Now again, our independent variable usually goes in the columns, and our dependent variable usually goes in the rows. So for this example, I'm going to look at the relationship between social class, put that as my independent variable, and health as my dependent variable. That is health, right? Yep. So far this has been exactly like what you did in the last chapter. However, this time we're going to go a little bit further. You're going to want to click on Statistics, and from there, click on chi-square. Then you're going to click Continue, and OK. So we get our summary up at the top with our sample size, the number of missing, etc., etc. We get our bivariate table, which is kind of nice that it does that for us. But what we're really interested in is this chi-square test box here at the bottom. And the figure that we're interested in, or the row that we're interested in, is this Pearson chi-square row. So it gives us the value of our obtained chi-square statistic. It gives us our degrees of freedom, and then it also gives us the result of the hypothesis test expressed as a p-value. Now, just like with t-tests and with analysis of variance, if this Pearson chi-square number is less than 0.05, we can reject the null hypothesis. So if this number is less than 0.05, we can essentially conclude that there is a relationship between these two variables. Because 0 is definitely less than 0.05, we can reject the null hypothesis and we can conclude, yes, there does appear to be a relationship between these two variables. You'll note here at the bottom, 0 cells have an expected count less than 5. Chi-square gets a little bit can get a little bit off track if the expected counts are too low, but that's not a problem in this situation. Although you should be aware, as it says in the notes, chi-square tends to be very sensitive to sample size. With a large enough sample size, pretty much anything will appear to be statistically significant. We have a very, very large sample in this data set, over 51,000 people. So that is something, if we were writing this up for submission to a journal, that we would probably want to address in the limitations section, that we have this enormous sample, and so we can't rule out the possibility that the size of our sample influenced this conclusion. But again, if this is less than 0.05, we can typically conclude there is a relationship between these two variables. So that should do it as far as what you need for your assignment. If you have any questions, feel free to talk to me, email me, etc.